Hello everyone, I am Mümtalkush. In this video, we will solve one problem in chapter 25. The upper plate of a parallel plate capacitor is a little bit tilted at one end by a distance alpha, where alpha is small as shown in the figure. Find an expression for the capacitance of this capacitor. In order to solve the problem, let's find the line equation of this line for the above plate. The perpendicular edges are alpha and A, and let the angle be theta. The slope of this line, which is tangent theta, is obtained as alpha over A. According to the general formula for the line equation, y equals m times x plus n, where n is the y-intercept of this line, which is D. And since m is alpha over a, we have the line equation as y equals alpha over a times x plus d. Now for the below plate, at a distance x, let's take an infinitesimal length dx and take another piece on the upper plate parallel to this piece. Because the width of these pieces is b, then the infinitesimal area dA is b times dx. And the distance between these pieces is y equals alpha over a x plus d. As a result, we can find the infinitesimal capacitance with this formula: epsilon 0 times dA over y. We know dA as b times dx and y as alpha over a times x plus d. Now we can take the integral of both sides. On the left hand side, the integral of dc is just c. E0 and b are constant, and they can be taken outside the integral sign. The integral is over x. Therefore, the integral limits are 0 and a. Now, in order to calculate the integral, let's introduce another variable u, which is alpha over a times x plus d. Therefore, du becomes alpha over a times dx. For the integral limits x equals 0, we have u0 as d, and for the upper limit a, we have ua as alpha plus d. Now, we can put these expressions into the integral. Here, a and alpha can be taken outside the integral sign. So, we get epsilon 0 times a times b over alpha times the integral du over u with the integral limits d and d plus alpha. The integral of 1 over u is ln u. So we have epsilon 0 times a over alpha times ln d plus alpha over d, where a times b is the total area of the plate. B. Show that as alpha goes 0, capacitance goes epsilon 0 times a over d as expected. Now we can write d plus alpha over d as 1 plus alpha over d. Remember that ln 1 plus x is approximately x when x is very small. In our problem, x is alpha over d, which is very small. Therefore, the capacitance becomes epsilon 0 times A over alpha times alpha over D, where alphas cancel each other. Therefore, we can say that as alpha goes 0, capacitance goes epsilon 0 times A over D as expected. Okay, that's all. Thank you for your attention. See you in the next video.